Let us now discuss about time constant of a given RC circuit and the transient period. We already discussed in the previous section that in a given RC circuit connected across a DC voltage source with EMF V, we close down the switch at t equal to 0, a current flows through it and it deposits charge plus Q minus Q on the capacitor, and the value of charge as a function of time is given as CV1 minus e to power minus t by RC. This we already discussed. This is an exponential increase in charge. So gradually after a long time it will reach the steady state value of charge at CV. Now in this situation, if we just substitute at t is equals to RC. So RC, the product of resistance and capacitance, is having the dimensions of time. So if we put t equals to RC, you can see the value of charge we are getting is CV1 minus e to power minus 1, that is 1 by E. And if we substitute the value of E over here, it is 1 minus 1 by 2.71. On simplifying, this will be CV1 minus 0.37. This is 0.63 CV. So you can see after a time of RC seconds, the capacitor gets charged up to 63% of the steady state value. If we again draw this figure in which we can plot the variation of charge as a function of time, which was an exponential curve, which is asymptotic at the steady state charge, which is CV. Here we can see at t is equals to RC seconds. If we just have a look, here the charge Q is 0.63 CV. This is a specific time which is also considered as a characteristic of a given RC circuit. The duration in which capacitor gets charged up to 63% of the steady state value is termed as time constant of the RC circuit. This is termed as time constant of the RC circuit, and is also denoted by the symbol tau, which is given as RC. Now in the same situation here, if we calculate at t is equals to 5 RC, if you substitute here t is equals to 5 RC, you can see the value of charge we are getting is CV 1 minus 1 by e to power 5, and numerically when you calculate it, the value will come out to be, this charge will be approximately 0.98 of CV. This is approximately 98 to 99% of the steady state value. So here you can see in 5 times of the time constant duration, the capacitor gets charged almost up to its full value, or 98% of the steady state value. It is 5 time constant 5 RC when the capacitor gets charged up to the full value, and remaining 1-2% charge it will acquire in almost infinite duration, which can be even neglected. So we consider 5 RC is the time up to which capacitor is almost fully charged. So this duration is considered as approx transient duration, in which the capacitor was being charged and beyond which we consider that steady state of capacitor is arrived. This is the way how we analyze, and you must remember, as time passes, the capacitor will be progressed towards an ideal steady state, because the ideal steady state, when no more variation of charge will take place at any value, will be attained after almost infinite duration. So this is just we have defined for practical cases or laboratory conditions in which we never wait for infinite duration so that capacitor will attain its final steady state.